2019. Place: Eagle Pass, Texas. Emergency: unknown online attack. The U.S. government has confirmed a cyber war. Please remain calm while the following events happen: leakage of private information through the dark web, inability to use certain electronic devices, and denial of internet service to some. The Central Intelligence Agency is working on protecting as many people as possible from this attack and will do their best to fight it. Beware.
Bruh, look at this dude. Wait till you see the.
Meanwhile,
After I finish this house, I'ma go.
Okay, same. I'll probably leave too.
OMG, what was that?
Let's go check it out.
Alright.
It's a message from Mr. Jimenez. Students, I have received intel. Don't panic, but we are being attacked by the AIs and are now trapped in the dimension of Minecraft. In order to save the world, we need to solve these calculus problems to safely return to the outside. Let's start, guys. You just have to believe in yourselves.
Nah, that's fake. Wait. Why can't I load the game menu?
Oh my god, are we in survival mode? And what's that over there?
Our lives are going down. Let's start the problem already.
Okay, so question 3, part A says that the integral from -6 to 5 of f of x dx is 7. And what we need to do is figure out the value of the integral from -6 to -2 of f of x dx. So we start off by breaking down that integral into the difference to get just from -6 to -2. We have to go from -6 to 5 and then just subtract off the integral from -2 to 5, and that will leave just the integral from -6 to -2 because that's what we're trying to find. Then we're going to plug in some values that we know. So this is 7 because that's given, and now we're going to go to the graph and figure out some of the areas. So this region, as we go from -2 to 5, these regions are exactly the same size, but one's above and one's below the x-axis, so they cancel out. Therefore, we don't need to find those values. So then also this region will cancel out, so all we really need to do is find what's left. So from 1 to 5, so 1 to 2, this region here is a square and then a triangle that has an area of 1. So this total part is 2, and then from 2 to 5, we're going to do a square minus 1/4 of the circle. So that's a 3 by 3 square. So we'll want to write 9. So the square minus the quarter of the circle. So the circle has a radius of 3. So the full circle would be 9 pi over 4. So that region is minus 9 pi over 4, and solve the answer of the integral to be 9 pi over 4 minus 4. Done! We lost 2 lives during that. We gotta hurry.
Okay, I'm going. Okay, so Part B of number 3 says to evaluate the integral from 3 to 5 of 2 times f prime of x plus 4. And since it's addition, we can break this into 2 separate integrals. The first one would be the integral from 3 to 5 of 2 times f prime of x dx, plus the second integral, which is the integral from 3 to 5 of 4 dx. So for the first integral, we can just move the 2 to the outside, and since the integral is an antiderivative, this f prime of x would just be f of x, and then solved from 3 to 5. And then adding the second integral, which 4 would just be 4x, solved to 3 to 5, which we would then get 2 parentheses f of 5 minus f of 3, close parentheses, plus 4 times 5 minus 4 times 3, which is just 20 minus 12, which is also 8. The next thing we need to do is evaluate. So we have 2 parentheses f of 5, which based on the graph is 0, minus f of 3, which is 3 minus radical 5, which is given to us in the problem's information, close parentheses, plus 8, which is the second integral evaluated. And then we simplify. So adding all like terms, the last thing we are left with is 2 radical 5 plus 2.
Alright guys, let me carry on from here. Alright, so the first step to solving this question is knowing how to find the absolute extrema, which we know happens at the endpoints in that critical value. In this problem, we are told to find the absolute extrema of the function g, but are not given g directly. Instead, they tell us that g of x is equivalent to the integral from -2 to x of f of t dt, which they do actually provide for us. Oh no, how are we going to do that? The answer is first fundamental theorem of calculus, which states that the derivative of the integral from a to x of f of t dt equals to f of x. Oof, that's hot. Basically, it tells you that the derivative of the integral from a, where a is a constant, to x of any function in terms of t is equivalent to f of x. I bet. Oh, and here's the extreme value theorem. Everyone forgets about that one. I see you, College Board. You're saying that the graph f that they give us is already the derivative of g, which is what we're looking for originally. Neat. Now we can start to identify our critical values, which is where the derivative of g, f of x, equals to 0 or undefined. Ooh, look, there they are. Let's write these down. X equals to -1, half, and 5. And our endpoints would just add the -2 at the beginning. Wait, why did we only have one endpoint? Oh, that's because the rightmost endpoint is a critical value as well. That makes sense. Alright, good. The last step is to evaluate the values of those endpoints and critical values. We will call these the candidates. How we evaluate each candidate? Using the graph of f. Since we know that the integral of f is equivalent to g, then we need to calculate the area under the curve from -2 to the value of x to find the values of g at those points. That will give each candidate its value. There they are. So we are given that g of -2 equals 0, g of -1 equals to half, g of half equals to -1 over 4, g of 5 equals to this ugly thing. The problem is asking for the absolute maximum candidate, and the winner is, drumroll, g of 5, for being the weirdest looking number out of all of them, and yet still giving us the idea that it's larger than the rest. Now we can justify. Since g is continuous on the interval -2 is less than or equal to x and less than or equal to 5, we know it is continuous because we took the derivative of it in the first place. Remember that differentiability implies continuity. G of 5 is the absolute maximum of g, and -2 is less than or equal to x and less than or equal to 5. And for problem D, they ask us to find the limit as x approaches 1 of 10 to the power of x minus 3 f prime of x over f of x minus arctangent of x. Wow, this problem is actually easy, lamau. The limit asks for the value that a function approaches rather than what it actually evaluates to. However, in this case, when we substitute all of x's of the function, you don't get any undefined values or indeterminate forms. The value of the limit is directly the value of the function when you plug in 1 to x. You can literally just plug in and get your answer. You just need to figure out what f of x and f prime of x are. The value of f at x equals 1 can be found through the graph already given. The value of the derivative of f at x equals 1 can be found through the slope of the graph already given at that point. Technically, in this problem, you don't have to evaluate it completely and leave it like that. But this is its actual value.
Yay, it's back to normal.
We did it, guys. The summer attack has been defeated. I'll see you Monday. I'm kinda tired. Love you 3000.